All right, let's look at chapter 9, problem number 9. We have a firm that's considering replacing an air conditioning machine, and our cash flows are already given. And problem 9 and 10 work together here for a reason. So in problem number 9, we can choose one or the other. They're mutually exclusive, and they both have 7 years worth of cash flows. And those cash flows are already given, so we don't have to do the calculations we've done in the previous problems. So we have the AC360 air conditioner. Its cash flows look like this. It costs $25,000 to install, and it's going to cost $5,000 to operate every year. So minus 5,000. Let me just not show the thousands to make this a little bit quicker. So in year 2, in year 3, in year 4, in year 5, in year 6, in year 7, you pay the $5,000 to operate it, but you can sell it at that point for 7, so the cash flow is 2,000. And the interest rate here, the K, is going to be 5%. So I want to determine if I should use the AC360 or the Raycool 8. Raycool 8 is more expensive. It costs $40,000 to install, and it's going to be cheaper to run. So this is the classic. You want the old one that's more expensive to operate, or you want the new fancy environmentally efficient one that costs more but the operating costs are less. So to determine that, you would want to do a calculation like this. So that's year 3, year 4, year 5, year 6, year 7, and then you can sell this thing for $9,000. So $7,000. So for the AC360, this is cash flow 0, and this is cash flow 1. It happens 6 times. This is cash flow 2, happens once. Make sure you put in the negative 25, negative 5,000, and positive 2,000. For the Raycool, this is cash flow 0. This is cash flow 1. It happens 6 times. This is cash flow 2. It happens once. Once again, look on page 183 if you need to. Make sure this is minus 40,000, minus 2,000, plus 7,000. If you do that, the net present value of the AC360 is going to come out to be negative, of course, because this is costing you money, minus 48,957.10. And the net present value here of the Raycool is minus 45,176.61. Now, I said never do a negative net present value project. All right. You've got to have the air conditioning unit to run everything else. So this is going to be a cost. So I want the smallest cost. The smallest cost is the net present value of the Raycool, which is 45,176. Here's a way I want you to think about that. If a salesman came to you and said, look, you can buy this AC360, and these are the cash flows you'd pay over the next 7 years, or you can write me a check right now for $48,957. You're indifferent. You don't care which one. If a salesman came to you with Raycool and says, these are the cash flows you'd have to pay over the next 7 years, or you could write me a check for this right now, you're indifferent. You don't care. You would rather write the check for the smaller amount. Okay, so now let's look at question number 10. So I'm going to have almost the exact same cash flows here. I'm just going to change this to question number 10 and make a few adjustments. Because number 10 says, look, the AC360 has a 5-year life. So we can look at this. And you still get to sell this thing for 7,000. So that's $2,000 right there. So this is still cash flow 0. This is cash flow 1, it happens 4 times. This is cash flow 2, it happens once. So my net present value is not minus 48,000. My net present value is minus 41,162.7. Okay, so now which one of these would you prefer? The difference is this. You can't make a comparison because one has 5 years, the other has 7 years. So I can't really compare these two net present values. So what can you do? You can assume, well, if I buy the AC360 after 5 years, what are you doing? You're buying a new air conditioner. And if you buy the AC360 again after 10 years, you're buying a new one. So let's assume that we want air conditioning forever and we just repeat this project. We just keep buying the AC360 every 5 years. Or we can choose the Raycool, which means after 7 years, we need a new machine, a new air conditioner. We buy the Raycool again. So we continue to do that. So here's the way we can look at it. We can say this machine lasts us 5 years. The interest rate is 5%. The future value is 0. Because remember what I said, you don't care if you make these payments or if you write one big check in year 5. I mean today. You don't care if you make these payments or write this one big check today. Okay, so if that's true, you don't care if you write this one big check today or solving this for payment, you would pay $9,507.55. Make sure I get these two separate here. You don't care if you make these payments, write one big check for $41,000, or if you make this payment over the next 5 years, every year for the next 5 years. That means you could repeat this project indefinitely and every year be paying $9,500. This is the equivalent annual cost. Let's look at it over here with the Raycool. You don't care if you make these payments, these cash flows right here, or if you write this one big check for $45,000, or if you wrote the same check every year for 7 years. So n is equal to 7, IY is equal to 5%, future value is equal to 0. Plug this in, my payment is equal to $7,807.41. So what this says, you can either make these payments over the next 7 years, so I should have a 6 and 7 there. These payments over the next 7 years, one big check today, or every year for 7 years make this payment. I could then repeat this project indefinitely by every 7 years buying a new machine, and so what I'm doing is I'm essentially paying $7,800 a year for air conditioning. If I do this one, I'm paying $9,500 a year for air conditioning. I would choose the cheaper, choose Raycool. Okay, now let's look at number 11, and number 11 is going to be extremely similar, except instead of losing money, we're making money. This is not something we're buying because we have to. It's a machine that's going to help our production process. And we have here the GSU 3300, and we have the UGA 3000 machine. We have to choose one of the two. And we're going to have the years as well. So in year 0, let's see, the GSU 3300 produces cash flows of $25,000 a year for 8 years and costs $100,000. So it costs $100,000. We have years 1, 2, 3, 4, 5, 6, 7, 8. I apologize, this is not going to be really neatly written, but I think you can follow it. $25,000 a year for 8 years. Or the UGA 3000 cost me $125,000 today. It goes for 9 years, and it's going to give me, oh, this is not, Let me get rid of this. These are not costs like in problem 10. Those are positive cash flows. So it's going to produce 25,000. This one's going to produce 27,000 every year, not just for year 8, but also in year 9. Now if I go the traditional way and I say, let's do GSU in red, and if I find the net present value of the GSU machine, it's going to be 49,282.46. How did I find that? Cash flow 0, cash flow 1 happens 8 times, and we have 7% cost. So I don't care if I spend $100,000 to get these 8 cash flows, or if you just write me a check for $49,000. Coming over here to the UGA, the net present value of the UGA machine is $50,911.27. I don't care if I write a check today for $125 and then get these 9 cash flows, or if you write me a check for this today. And again, this is cash flow 0. This is cash flow 1. It happens 9 times. 7% cost of capital. That should get you the net present value. I can't compare those because one lasts for 8 years, one for 9. If I buy the GSU machine, I have to buy another machine at year 9, repeat the project. Right? So what I can do is I can find my equivalent annual series. I can say, well, if I do GSU 3300 and I repeat it indefinitely. So n is equal to 9. I'm sorry, n is equal to 8. I can say 7% cost of capital, future value is 0. Plug this in, solve for payment, and this is going to be $8,253.22. So what does this mean? I don't care if I write a check for $100,000 today, get these 8 cash flows. If you write me a check for this amount today, or if every year for the next 8 years I get $8,200, those are all the same to me. So essentially what this machine provides to me is $8,200 a year forever, because I can, every 8 years when the thing breaks down, I buy a new one just like it, and I'm always producing $8,200. I'm assuming, of course, the same cash flows. What about the GSU 3000? Well, it produces cash flows for 9 years. Its weighted average cost of capital is still 7%. The future value is 0. I solve for payment, and the payment here is $7,008. Write that 8 a little bit better. $7,814.19. So what is this telling me? This is telling me that I don't care if I write a check for $125 today and receive these 9 payments of $27,000, or if you write me a check for $50,000 today, this amount. Receiving $50,911 today is the same thing as getting $7,800 a year for the next 9 years. I'm indifferent between those 3 choices. I can then repeat this project and buy the UGA machine every time it breaks down, after the end of its life at 9 years. So I'm essentially coming up with $7,800 per year forever for the UGA. I'm making $8,200 a year forever for the GSU. GSU is better than UGA. So that's the conclusion. Alright, so that's number 11.